So before I start, just a few hands up so I get an idea, I can't see anything, of who I'm talking to. So who's in the broadcast space? Broadly, we probably all are in some way or another. And software side, and operational side, and I don't know, what other sections do we have here? Outside broadcast, I think. I'm sort of stabbing randomly in the dark there. Are there any other OTT operators? Because obviously that's what this session is going to be about. Okay, so by word of introduction, I'm going to flick the slides. I'll do the slides for me. So by word of introduction, some of you have suffered my writing for many years in streaming media. I'm Don Robinson, contributing editor for streaming media, as one of several hats I wear. And we're also sponsoring today with my sellmux.com hat on, and there'll be a session tomorrow after lunch about 2:30, which is going to have a live feed coming in from New York if the toys work. And we'll be talking a lot about live link aggregators and outside broadcast technology using IP and so on with some quite interesting people. But my sort of major job is part of a company called Ideas, little blue logo in the top left there. My colleague Adrian here will introduce himself more fully in a second as well. We are a software company. We describe ourselves as a software-defined media workflow company. So you probably notice a few trends in that terminology. We build large workflows. One of them we're going to talk about in depth in a second. Another space that we've operated in is NASDAQ and Reuters market reporting workflow. We deliver about 35,000 live events a year for those guys in an entirely cloud-built platform, which has been running for about 4 years. So feel free to come up and talk to us about what we can do for your media workflow if that's interesting. So this session, we're going to talk about in some detail about what we've done for Arqiva and helping them to deliver their hybrid TV platform for the OTT market. So Step, I'm going to let you guys introduce yourselves as you come up. Otherwise, we'll be paying too much dancing. There we go. So we're going to have a look at what OTT is, first of all. I'm just going to make sure we're all on the same page. There's several meanings for OTT in the space. And I want to make sure we're all sort of on the same page as to what we talk about when we're talking about OTT. And then Oz is going to talk a little bit about Arqiva and what those guys are trying to achieve in the broadcast space. And then Adrian's going to step up and talk about how we've actually delivered that. And we're going to go on quite a deep technical dive with Adrian. So with no further ado, I'm going to just talk a little bit about OTT. There's a diagram that went out in very small print on streamingmedia.com a few weeks ago. And I was asked to blow it up by a few people. So there it is. Get your iPhones out if you want a copy. There's some different models. I use this to sort of talk about different models of distribution in the IP online space and so on. So here we're talking about, we've got different models for, I don't want to go into too much detail here because this could go on a bit, but we've got an IPTV environment where you've got controlled and managed network right through to the edge. We've got straight to internet down sort of around the bottom. So something more like Netflix and so on, which you could call it an OTT services, and I think in some environments it is delivered as an OTT service in what I would define as OTT. And we've got sort of hybrids, which the guys are going to explain in much more detail in a few seconds. But hybrids, we're taking broadcast baseband video. We're generally trying to get that issued to TV sets over broadcast media. So that you can then access content through an internet connection on the back of your smart TV or your set-top box and so on and so forth. And then the content itself is delivered over IP. Usually that's over public internet. Sometimes that might be over a more managed environment like an operator CDN. So that's what we talk about when we're talking about OTT. If you're looking for mobile backhaul, you're in the wrong room. Essentially. So I think with no further ado, I'm going to ask Oz to introduce himself and talk a little bit about Arqiva.
So hi, I'm Osman Senchadden. I'm from Arqiva. I've spent about 16 years in the organisation so far, working my way through different facets of the broadcast industry. Started my life, cut my teeth in the world of operations and terrestrial broadcast, looking after analogue, then digital TV transmitters. Moved into the satellite space where we did the same thing, went from analog to digital. And then I got heavily involved in product development where we started to develop things like IP over satellite. And this is where I first started to get into streaming. It was in the very late 90s, early 2000, where we started to look at multicast IP streaming over satellite, looking at streaming media platforms, things that could get content out onto the internet, deliver new ways of getting our broadcast customers' content out onto the internet. Now, for those of you who don't know who Arqiva is, This is a little subset of what we do. We have our fingers in various pies, from Wi-Fi technologies, smart metering, all sorts, but coming from the broadcast kind of world, this is the kind of stuff we do. We operate satellite uplinks. We transmit in Arkiva several hundred TV channels up to satellite all over the world. A large portion of the channels you watch on, for example, Sky or Freesat, if they don't have the Sky logo on, they're probably coming from our facility where we take the content from the broadcasters, encode it, uplink it, and away it goes. And you can see on the picture there, we've got our control rooms, 24 hours a day, manned operations. We're very much in that world of high availability services, robust, rugged, 24-hour day type operations. On the very right,
Hybrid there.
that is hybrid just there, absolutely. If you look on the right, you can see the transmitter towers. Arkiva was responsible for the digital switchover project, where we took things from analog to digital and so on. And there we have Emily Moore transmitter tower, Crystal Palace transmitter tower. Again, it's all about those high availability broadcast networks. The question is, when was the last time you saw ITV, Channel 4, those kind of channels go off the air? It just doesn't happen anymore. In the days when I was growing up, you had the caption on the bottom of the screen with the doobie-doobie music playing, telling you sorry for the technical problem. Those kind of things don't happen anymore, and we're in a world where we have to architect our networks and our platforms to be as robust as this. And the reason I mention this is because in the world of OTT, even though we're delivering through the internet, we can't put that in a second place to our normal broadcast services, because from our perspective, if we're delivering an OTT service over the internet to a user who's kind of connected TV, is used to watching a digital terrestrial TV channel 24 hours a day and it's working, they would expect the same thing from their OTT services, as would our broadcast customers who are trusting us to not only get their transmissions out over the air, but also out into the internet domain as well. So I thought I'd mention this to you guys so you understand the kind of picture of what Arkiva is, what it is we do, sort of scale of things that we do. And from our perspective today, the little bit in the middle with the balloons, it's particularly the Freeview platform that we're going to talk about here. Now, Arkiva is actually a MUX operator where there's 7 MUXes, maybe more now in the UK, which with the HD MUXes have come about. But Arkiva is the MUX operator for 2 of the commercial MUXes and also operates the public service broadcaster MUX carrying the ITV Channel 4 type services as well. So we have these type of operations looking after all of the encoding and the multiplexing and the transmission of those type of services. Now this was really cool for us because we operate these multiplexes and we have this type of capacity. It meant that we could look at Freeview as a platform, as a model that we could then apply other additional services to, and this is where the whole hybrid piece comes into play. So for Arkiva, this is how the world looks like to us. If you look on the very left-hand side, you can see things right to the old black and white days of TV in the 50s. You'll see in 2000 there, we cut our teeth a little bit on streaming with Windows Media and Real Networks formats. Probably a bit too early when you now look at it in a timeline, which is why that wasn't as successful as we'd have hoped. But you go into the future and you can see it's all very much about the online play. Some of our biggest customers, the Channel 4s, ITVs, these kind of guys, it's all about streaming for these guys as well as terrestrial broadcast or satellite broadcasting. So as a business for Arkiva, we're also looking at a space where we combine all these technologies together and provide these additional services. So talking about Freeview, well, there's a technology underlying Freeview that some people may be unaware of. It's called MHEG-IC. MHEG's, I can only describe it as a kind of programming language that it looks more like assembly language, so it's not something I'm not that strong on, but it's the gateway for us to get into the Freeview platform. Within the Freeview standards, and actually this actually applies to Freesat as well, there's a capability to, alongside the video and audio transmission, to transmit a little data component. It's a very low bitrate little data application that's transmitted with the video and audio and actually lands on a set-top box, and it checks if the set-top box is connectable. Is it connected? Can it get out onto the internet? Can it fire off and go and do other things? This application also has some security wrappers around it. It contains, for example, a white list of servers that you can talk to on the internet because you don't want someone spoofing your connections. There's digital certificates and things like that that we transmit over the air as well, because once they're transmitted over the air, it's almost like you have a form of security stroke geo-blocking of a sort, because you can only receive the Freeview transmissions in the UK, which means that only users with UK TV reception could access those services and get access to the keys that allow them to decrypt services, for example. So for us, this is beautiful because it's digital terrestrial TV, which is the world we know and love so well, combined with a technology that lets us get out onto the internet. It really is a perfect fit for a company like Arkiva. Now, from our perspective, in the world of Freeview, you're tuning on a channel number. You might tune to channel, 123, and you'll get your Freeview service. So we've tried to make the fit of that as seamless as we can, so that the users at home, when they're flicking and choosing channels, whether it's coming over the air through the antenna or coming back over the internet, it's as seamless as possible. So in our world, you tune to what's called a logical channel number. It's basically a channel number. You tune to channel 123, and something starts to happen, the magic. It's where the box starts to connect to the internet, and it goes off and gets potentially live video streams, video on demand portals, services that I'll tell you a little bit more about as we go forward. So the kind of products and features that we're interested in particular, well, if you think at the moment we've got all these digital terrestrial TV channels being broadcast through the air, we want to be able to add new functionality to them. You've seen the BBC Red Button, generally speaking, not connected version of a red button. It's an information service. Well, it's a similar thing. People are used at home to pressing the red button and getting access to some interactive type service. So from our perspective, present a red button, users at home know what to do, and they're into a whole new world. So from our perspective, this could be potentially a linear stream. It could be a part-time channel that we extend. Some of you may have seen on Freeview, you get channels that aren't 24 hours a day. For example, 7 o'clock in the evening, they may go to a caption on the screen that says, back at 7 o'clock tomorrow morning, and that's dead time for that channel. On some platforms, for example on satellite, these channels might be broadcasting 24 hours a day, but on the Freeview world, they're not. One of the things we've been able to do through IP streaming and through this MHEG technology is allow these channels to kind of virtually extend their service into a 24-hour-day window. So they're on DTT over the antenna for part of the day, and as soon as their day is over and it goes to caption, so people with non-connected boxes would still get the caption. Those who are connected would just roll over into an IP stream and can continue watching that channel. This is fantastic for our customers. Linear IP channels and portals. Well, a linear channel, if you tune to a channel number, it doesn't just have to come over the antenna, it can just come back over the internet. So this is where you tap in your channel number, live stream begins. It feels as seamless as a normal TV channel. In some cases, we've been able to combine multi-channels onto one channel number. So you'll go to another channel number, and you'll be faced with a screen which has a selection of services in there, maybe 3 channels in a portal. So you actually suddenly get channels within a channel that we can start to put together. And this is great for customers who want to bring a brand feel together or have more than one channel. We did things, for example, for QVC. QVC had, I think, their primary QVC channel and QVC Beauty on air. QVC Beauty was a part-time channel that we extended to 24 hours a day, and then we added QVC Style and Extra as wingmen on a UI on the screen, which I'll give you a little look at in a bit as well. So we took them not only to 24 hours a day virtually, if you will, but also added their additional 2 channels on there also. VOD portals as well. Now that's really interesting for us because within Archiva we do a lot of play out. We take content in from customers, we transcode it, encode it, store it, do all these things and munge it together. If we can present all this stuff out into our networks and put it out onto the internet, we're able to provide VOD portals as well in a similar way. It's basically a red button. At the moment, when you think of the kind of iPlayer experience, you kind of leave the BBC channel to go away and use iPlayer. In this world, we're looking at ways that potentially you could be on a channel and you could press a red button and it takes you into the catch-up service for that channel without having to navigate anywhere else, without you having to go for an app store. This is all built into the actual channel itself. So again, a good user experience for end users, brilliant for our customers who are looking to add value to their services. And on top of that, we've developed subscription pay services where people can go online, register on a website for a channel that may be encrypted, and then they'll be faced with a PIN number, and when they go to the channel on the TV, they can enter their PIN number, and they can go away and watch the subscription channel. So we have encryption capabilities and subscription there also. There we go. So a little example of some of the channels and a look and feel of some of the services we have today. You can see some of the channels there. We have a bespoke application. We did some work for Box TV, the music channel, and put some additional music channels in there. It's on channel 18 on Freeview. If you press the red button, you're suddenly faced with a portal and a few extra channels in there. It's similar for some of the other portals on the right as well with QVC and CCTV. And in the middle are some single linear streaming channels. Motors TV, Vintage TV, the music channel we launched just last week. These are channels that weren't normally on the Freeview platform. May not be a platform that they could normally potentially afford to get onto in their business models. But we've opened the door to these guys to get into the Freeview market now through their channels. And you can see around the edge some of the look and feels. The kind of free channel portal on the very top right-hand side is the QVC one. We did a bespoke one for Racing UK, which has real-time sort of racing information built in there. Top left is the 4 music channel where you can navigate up and down and pick the services. So you're literally flicking from digital terrestrial TV and IP streams very, very seamlessly. And Motors TV is a single linear stream as well that we recently launched. So how does it work? Well, in our little world of broadcast, if you ignore the box at the very bottom of the carousel, DTT multiplexers and transmitters, this is our kind of our bread and butter really. But the carousel at the bottom, it's basically a file playout system. We're looping a little series of files over the air 24 hours a day, and it's going out through the transmitter network. That's kind of the easy bit, I think. Then we get to the IP part of the platform, and this is where we take content in from our customers. Now, generally, these come into us on fiber, SDI. Some of them we downlink off satellite. We've got quite a nice facility to be able to bring those feeds into our premises. They go through our transcode systems, which Adrian will tell you about shortly, because we worked with the guys to make these work seamlessly across the market base of devices that are out there, and into streaming servers that then package it all up ready to send out to the internet. We have things like application servers and database servers. All of our applications and all of our systems are data-driven. And we have analytics systems as well. So as people are watching TV, just like in the internet online PC type experience, you're gathering those kind of analytics, the kind of things you might see in Google Analytics. We're now able to do a similar thing. So where previously broadcasters were tied around barb data, it's that kind of metric where there's X thousands of people in a home and they extrapolate it out. We can actually provide absolute pinpoint accurate information about how many people watch that service at what time of day, and even down to what transmitter area coverage were they in. For example, if they were watching off the Oxford transmitter, we can get an identifier that says the transmitter ID, and we can actually show the coverage map and says that viewer was within that area. So in the future, if we start to look to develop sort of targeted advertising or regionalised advertising, those are the kind of things that could potentially play into that model in the future. And there we go, off to the internet and to a standard Freeview HD set-top box or TV. And that's the important thing to note here. We haven't done anything special with any client devices. These are off-the-shelf Freeview HD TVs and set-top boxes that you can go to Currys and buy tomorrow, plug it straight into the internet, and literally away you go without any app stores, without any other intervention. That's the real key for this for us. So from a platform perspective, this is kind of what we look like. bit of a map, but on the very right at the top, you can see the broadcast application and our DTT multiplexes. So currently we transmit, I think it's 4 out of 7 or 8 of the MUXs in the UK. On the very top, you've got the broadcaster. These are our broadcast customers that we know and love, and we can take their feeds in either off satellite, as I said, or fiber as a transport stream coming into our buildings. And they also provide their XML data for us, because in the same way when you watch a TV channel and you go to the program guide and you can see what's on now and next, we do the same thing within the internet IP domain as well. So you still have that now next bar coming up. And we take EPG XML data, electronic program guide data, from our customers. They provide it in either the conventional FreeSat or Freeview formats that they already work to, and we can pass all that data, take it into our databases, and present it out to our applications. So from our perspective, we have the encoding head end, H.264 encoding. We can apply encryption to those services as well, feeding down to our streaming servers where we stream in a sort of HTTP format, which is the standard for the Freeview HD devices, HLS as well as other formats if we want to get out onto tablets and PCs also. We take, on the very right, you see the little yellow boxes. These are our little product subsets that we add on the top, single channels, portals, VOD portals, any bespoke apps that if any customers have a particular requirement, we can develop to. And they feed down to our application servers, where we currently serve out the MHEG versions, but we also have HTML versions as well. So as the world moves from MHEG to, say, HBBTV, we're ready to address that market already by being able to develop HTML applications that look and feel exactly the same as the MHEG behaviors. And then on the very right, you've got the reporting systems, all the analytics and database, catching all that data that we can present to our customers, showing how all of this stuff works. So that takes me over to Adrian, who's going to tell you about the pain and the dilemmas we've been through to make this stuff work. Thank you.
Thank you, Oz. Yes, so absolutely. The headline sort of says it all, and the devil was very much in the detail here. And what I'll describe as some of the journey from kind of concept or early stage implementation to making something that's really kind of enterprise class, broadcaster quality, and as close to ubiquitous as possible. I think something that Oz said 2 or 3 times is one of the things that's a big differentiator for this, is if you go out and buy a TV today, it's almost impossible not to have something with this capability, and I think that's still a very, very important capability. So I will talk very briefly about my company. So what does Ideas do? We build large-scale media workflows. The bigger the better. So, for example, I believe, are still responsible for the largest live digital media workflow on Amazon. That's with NASDAQ. We do about 35,000 live events a year with them for all of their investor relations, broadcasting, and so on. And we like to build very, very specific workflows that will match, the IT will match to the particular enterprise's business process underneath, rather than the other way around. So all of our initial exploration will be, what's the business problem you're trying to solve? How do you go about doing that? Where can you work well? Maybe meeting with the MCR teams and so on as early as possible. And then saying, okay, given that, what we want to do is to implement IT in an invisible, as invisible as possible, so that actually what happens is you keep running your business the way you want to run your business, and the IT takes care of itself. And specialities within that are very much around scalability, using either public and private cloud. So Arqiva is a good example of private cloud infrastructure, partly because of the whole sort of broadcast requirements underneath. And in order to have really, really, really reliable systems, I'm a very firm believer that what you have to do is actually embrace the fact that something's going to go wrong and make sure that your system is self-healing. So don't try and just put more and more and more infrastructure in the way so that you cross your fingers and it's never going to go wrong, and then when it does go wrong, everybody panics. It's accept that things are going to go wrong and make sure nobody notices. At the same time, what you want, you have these large-scale systems, you want them to feel and to operate as though they're nice, small, standalone, there's just a single box and it does this very simple thing. So what we try and work really hard on is a sense of a single point of control, and I put single very much in inverted commas because obviously we would never do any one instance of anything in the solution, because if that box fails, that would be bad. But you want it to feel like there's a single point of control, despite the fact there's actually lots and lots and lots of stuff going on. And control is a word you'll hear me use lots throughout this session. And when, actually the Arqiva case studies a particularly apt one, and I won't steal my own thunder, but the approach we've taken is that everything is our own code. So we are in control of the end-to-end life cycle. All the ones and noughts that come into our system, from the time they arrive to the time they leave, it's all our own code. And so that gives our customers a single point of responsibility. If there's anything that's gone wrong, then they can come and talk to us about it. It's not, oh, actually that bit's in Flash Media Server or something, and that bit's somewhere else, and I'm not quite sure what I can do about it. It's actually, we'll just make the thing work right from soup to nuts. The one exception to that is codecs. There's lots and lots and lots of PhDs been spent putting together all the various different codecs that are out there in the market. And we also don't personally feel that codecs are a differentiating property, because most of the codecs that are out there are actually used by most of the vendors. And so what we do is try and get out of the way of the technology. Certain codec choices are better for certain specific customer situations, and so we'll say, right, for this particular use case, we would use X, Y, Z. Maybe that's a GPU accelerated one for certain use cases. Here, control, again that word, and customization was incredibly important. So most of the encoding here is done with X264 as a codec because it gives immense flexibility. And the other thing we don't believe in is going through a kind of Esperanto layer. We don't want to sort of go in from our software through some generic library to a codec, because then actually one of the things we found early on in our work in this particular sector is that you end up fighting with the generic layer. We want to be able to make the raw ones and noughts do exactly what we want them to. That control is very, very important to us. So whenever we work with a codec, be that from Main Concept or Rovi or Microsoft or whoever, we will always integrate directly with those. So if the codec is capable of a particular behavior, so are we. One of the things that was, I'm going to swap the order of the last 2 points. We come from a very technical background, so I've run companies in the retail space, in the financial services space, and in the mobile telecom space. And we've been throughout all of those companies, we've been very, very focused on really high availability, things that just keep running and running and running and running, because when you go to a cash point machine or you go to your online bank, you expect to be able to go there, do something, and it just works. And one of the technology, the only kind of technical road to Damascus experience I've ever had in my life was when I came across a language called Erlang about 5 or 6 years ago, which has got, I won't go into the details, but it's got a massive telco background. And so, for example, Ericsson, they do about 60% of the world's mobile phone calls go through Ericsson switches. And those Ericsson switches have a 9 nines availability guarantee. They have a 15-year life cycle, which means about 2 seconds downtime in 15 years, gives you 9 nines. And if they don't meet that, they literally have to pay millions of pounds back to the operators. So there's some technology that allows you to build unbelievably robust, available self-healing systems that we've been using for a long time now as part of that strategy. What was interesting in this particular context was I think I understood the meaning of the words broadcast quality for the first time, partly because Oz rammed it down my throat a few times, and a friend and colleague, John Holden Dye in particular, who's been there and done that, let us know in no uncertain terms exactly what that meant. And one of the expectations that we walked into this project with, and one of the learnings, was that surely if you're talking to a smart TV, well, actually what a smart TV probably is in reality is a little Linux box, and it's running some kind of microkernel, and you send it some stuff, and it's just like sending content to a TV, isn't it? To a tablet or a PC, isn't it? Oh no, it's not. Not even a little bit. And that came as a reasonably big shock to us. I'm now prepared to tell him. Because actually the way TVs and set-top boxes still work today is they are bits of hardware that expect a broadcast signal which has nice old-fashioned things like interrupt cycles in it. You get a clock pulse exactly every 25 milliseconds, and if you don't get a clock pulse exactly every 25 milliseconds, some of these TVs you literally have to switch off at the wall.
If they don't switch off for you.
If they don't switch off for you. So if you get the details of the details of the details wrong with these sorts of devices, you can make them do really horrible things that involve hard resets and stuff like that to make them recover. And that's because what they have is a little analog to digital chip, which is expecting your signal, your input, to actually drive its clock for it. And so your tolerances for operating with these kinds of devices, televisions and set-top boxes, televisions in particular, very, very, very small. And with control, oh my word, that didn't come up very nicely in the slide at all, but control on its own is of no interest unless you know what's going on. We've got this large-scale system, there's hundreds of servers running and Lord knows how many different geographic locations and so on. You need to be able to do two things. You need to be able to sit at 1,000 feet and have a little Christmas tree of green lights that's saying the world is healthy. So one of the major efforts that we put in place was to work with Arqiva's MCR to make sure that they just sat there and they had the usual screens, and now there's another couple of little Christmas tree baubles over on the side, and they behave exactly like all the other Christmas tree baubles do. And if something's gone wrong, one of those little baubles goes from green to orange to red to whatever it might be, depending on the severity of the issue. At the same time as having this 10,000-foot view, if something does go wrong, what you need to be able to do is 30 seconds later say, actually, what's happening is it's the transcode of the audio coming in because what should be arriving is an MPEG-2 audio stream, and actually what we're being given is God knows whatever audio stream. So you need to be able to go, and you can't see it on this slide at all, from the very high-level view down to the very, very detailed level view in next to no time. And if you could see what the slide says, each of those little boxes is a part of a video and audio transcode workflow. You've got various different sources that will switch on. There's various different formats that we're producing the output in. And we can provide real-time stats automatically for everything that goes into every one of those steps and everything that comes out of one of those steps. So it becomes very, very easy to say, that's great, the content's leaving the encoder just fine, but it's not getting to the content distribution server or whatever else it may be. And we can go from the very high level to the very, very detailed in no time at all. So to come back to this specific project, the big driver for Arqiva is reach. Yeah, there's no point in going, it's fantastic, we've got this ubiquitous product that should work on every television, when in theory, in actuality, it doesn't. And again, I think we were possibly all slightly naive on this particular part of the journey, which was there is a very detailed standards definition based around how these devices ought to behave, done by the DTG. It's called the D-Book, and this was version 6.2, and they're now on version 7 point something or other. And all the television manufacturers operate against this particular standard. But rather than lies, damn lies, and statistics, what we discovered here was lies, damn lies, and standard. Because when our first implementation, what we did is we, quotes, just followed the standards, at which point we were working on about 16% of target devices by popularity. And that wasn't where any of us wanted to be whatsoever. It was kind of, well, we followed all the rules, yeah, but it doesn't work on this Panasonic or on this particular version of a Samsung or whatever else it may was, and it was a bit of a headache. And what became quite clear is that there was a bit of a market anomaly, because it's not that obvious what the motivation is for the television manufacturers. Because Samsung, for example, would love you to get all of their content through the Samsung portal. They don't want you just being able to turn on a Freeview channel, go there and go, bing, here's a new channel. And the day after, bing, here's another 5 new channels, and so on and so forth. And now this was 12 hours a day, and now it's 24 hours a day. They don't want that. They want to be able to control the content. And I don't know if you remember the early evolution of the music industry. When music started to be sold online for the first time, you had this rather weird phenomenon that if you wanted to buy XYZ artist's records, you had to know that he was signed to EMI. I think George Michael was signed to EMI. And the only website you could buy George Michael's music from online was EMI's. And everybody tried to create these little islands of control that I think even at the time, everybody knew that they had absolutely no hope whatsoever of winning that control race. But everybody was motivated to try and keep this island as close as possible. And so you have the same with the set-top box manufacturers and the TV manufacturers, in particular the TV manufacturers, who want you to have a great experience with their content, and they don't really care what your experience is like with anybody else's content. And so we had to go through an exercise, it wasn't that long, it was a couple of months probably, where we had rooms full of kit, just, and then the DTG's got, several hundred devices as well that you can go in and rent. 370, I think. How many? 370, jolly good. Where we kind of threw the standards book in the bin, and we said, okay, what can we do to make this particular telly work? And once we've made that particular telly work, what can we do to make this particular telly work? And we kind of went down through the hit list of most popular devices and internal chipsets and so on. And through a process of kind of pragmatism and fine-grained control, that was right down to settings I'd never heard of in H.264 encoding, and I know a reasonable amount about H.264 encoding. And you tweak some of these, and you do this, and you do the other, and then you recognize that this was a such and such and such a device. And a couple of months later, we went from having about 16% of target devices working smoothly. There's some great work done on the app side as well by one of Oz's colleagues called Stuart, who, again, the MHEG engine is a standard, and again, everybody interpreted it differently, possibly willfully so. And so there was an exercise of a few months where we went from working on really quite a small percentage of those target devices to essentially all of them. The 4% is getting smaller because they tend to be older devices that are going out of...
Yeah, I think the stage we're at now is devices that don't work are the ones that could never work. They don't have the chips soldered in and things like that. So
Yes, yeah, they can't help that one in software. So what could possibly go wrong? We're talking about a whole broadcast infrastructure here, and we want to do all sorts of marvellous things, and we have very, very high expectations, and then it doesn't quite deliver quite according to plan. This is part of Arqiva's critical national infrastructure, which they run, I think, essentially on behalf of the UK government or something, to make sure. Yeah, so if you miss EastEnders because it doesn't work, then people get very upset, and it will be talked about in Parliament and so on. And this has to sit along, in amongst all of that, and just work, and just work. And the only way you can make stuff just work and just work is to ensure that there's resilience at absolutely every step in the chain. So we've got to get that content from somewhere. Now, Arqiva are fantastic people to be able to offer that because there's pretty much no content in the world that isn't already passing through their buildings. So getting the content is something that's really pretty well sorted. But we'll do all of that in 2 different locations. We then have to take that content in and encode it, and we'll do all of that in 2 different locations. And then we've got to serve that content out to the end devices, and we'll do all of that in 2 clusters in 2 different locations. And over on the right, there's another diagram you won't be able to see, or I hope understand, where basically we cross the wires all over the place. If I can't get it from A, I'll get it from B, and I'll do that at every single stage in the journey. So that most failures, the application layer, being what's running in the television, isn't even aware that there's been an issue. We'll swap the streams under the covers, nobody notices. You might get a couple of frames of slight glitch, but then it just continues. Okay, it just needs to keep running and running and running. But all the way up to, if one whole half of the infrastructure dies, the application will switch over to the other side of the infrastructure within a second or so. And so what you can do is deliver an incredibly reliable service. What we're doing is we're taking a domain that typically has not been that quality-centric or that reliable-centric, and we're treating it, we're coming at it like a broadcaster would, because that essentially is what Arqiva is. And I'm very, very proud to say that a year and a half or more into the life of this particular project, we've had no downtime, none whatsoever. And as a result, Arqiva are able to offer, built on top of commodity kit. We haven't got millions of pounds worth of mainframes or anything like that sat underneath this. On top of commodity kit, we can offer a really quite aggressive service level to end customers, which caused us sort of a problem. I certainly didn't see this one coming. Because what we have is a whole bunch of A stuff and a whole bunch of B stuff, and we've used the B stuff once, twice. There was a big there was a big fade out in one of the down encodings. I can't remember what exactly it was.
There was some security patches on one side as well, things like that.
So we've used the A and Bs for a little bit of planned maintenance, but we've basically, the Bs just sat there, and it hasn't really been offering value. So the last 3 or 4 minutes that I'll just talk about what we think is the right way to address that kind of challenge. So the base layer has to be, it just works, and it just runs, and it just gets on with the job. But actually, maybe we can be a little bit more greedy than that. Let's not think about, here's my A's and here's my B's, and never the twain shall meet, and they'll go off and do their own thing. Let's talk about compute capacity, reliable compute capacity that's distributed across multiple locations, so I get certain physical securities out of that. But then let's sit there and really focus on how we can make those assets work as hard as possible for the business. And there's been a couple of technological changes in the last 2 years that I think really changed the way you can go about addressing this space. First of all, along came hardware, and then everyone said, oh no, hardware's the wrong way to go. We have to abstract those into VMs. But VMs are great, but they give you a reactivity time measured in minutes. And I cannot afford to have downtime measured in minutes. That's just not acceptable. I have to have downtime that looks like just a glitch in the stream. So there's technology that's been around for a while called containers. I won't go into the details of it, but basically with a VM, I can have half of a box pretending to be a Windows box and the other half pretending to be a Linux server, for example. If at the cost of saying, actually, I know that this box is running Linux or Red Hat or whatever it might be, what I can do with containers is I can run lots and lots and lots of equally sandboxed instances on that server that all have to be running Linux. That's the cost. They can actually be running very, very different flavors of Linux and so on, but they all have to be based on the same kernel. At that point, I can instantiate new work jobs and throw them away again, not in minutes, which is where I am with a VM-based infrastructure, but literally in milliseconds. So what that means under the covers is that so long as your monitoring and your control and your quality assurance is good enough, what I can do is I can say, okay, I'll have my A chain delivering all my channels because that's its job. But the B chain, right now, we've got this great VOD capability. I'll have it sitting there churning on VOD assets for me. And then, oh, hold on, one of the hard drive on such and such a server in my A chain has died. That's not great. So what I'll do is I'll take one of the jobs on the B chain and I'm going to throw it in the bin because it's just a VOD job. I'll queue it up again. It'll be done a few seconds later on another box. But 20, 50 milliseconds later, this box that had nothing to do with my workflow whatsoever over on the B chain suddenly becomes, oh, I'm the new channel 123 encoder. And it will sit there and pick up from where the other dedicated encoder, or indeed not dedicated, but the original encoder had left off, and suddenly allow me to pick up within the space of a GOP. And reacting more quickly than within the space of a GOP is of no benefit to anybody because the televisions won't pick up more quickly than that. So there's some technology just arrived that's now, I think, production ready in the last 6-9 months that allows you to do just-in-time DR. And I think that's a very, very exciting capability. And what it allows you to do is to focus on, I have some generic off-the-shelf compute capability, and what I'm going to do is I'm going to run that in the way that is, delivers me the best value to my organization right now, and a quarter of a second later, that decision might change. And so that's kind of the journey we went on. It's been fun. It's been an enjoyable partner to work with, Arqiva. I think we've mutually had a pretty good time putting it together. So happy to take questions. I think we have, about 4 minutes, I think, before our... Phil.
Adrian, thanks for that, Ross. If I'll just touch briefly on two things. One is, what's your strategy for use of CDNs to make the uptime as good as possible? And secondly, did you come up with a secret H.264 source that worked on all the different devices, or are you actually having to make lots and lots of different flavors to cover all the different devices?
Let me take the second one first, which is we went for an Esperanto, which was lowest common denominator. Well, not lowest common denominator, but lowest, most flavoursome, widely compatible denominator. So we did have to make a couple of pragmatic decisions that are sat in that 4%, where while we might have been able, some of them have restrictions like they can only have, B frame chains 1 or 2 long, and the quality of your encode just collapses under those sorts of infrastructures. And I think part of the interesting thing that's now changed, because I suspect Arqiva now is the reference implementation against which TV manufacturers will work out whether their stuff works or not. But I suspect in a lot of cases, while the manufacturers may have had access to a standard, they didn't really have access to a reference, somewhere where you could just go and does it work in the wild. This is all so leading edge and so new that that wasn't there. And I think what a lot of them did literally was plug a DVD player in and get DVD type streams. So there are aspects of the encoding that we do that are DVD centric, which have no place being there other than pragmatic choices. CDNs, I know nothing about CDNs. These two people know a lot about them. That's why I'll shut up.
No, there is some strategic work going on in Arqiva at the moment with regard to CDNs. Arqiva is actually an ISP. We're not a consumer ISP, but we do have ISP capabilities, which gives us the advantage that we can actually conduct our own peering with network operators and other networks. So at the moment, we're trying to, frankly, have a look at the look at the market, look at the technology, look at the capabilities of CDNs, and look at their networks that we want to get into. I mentioned analytics earlier. It's really good for us now because we can start to see which networks viewers are coming in from. And we can make the decision of, do we want to peer directly into those networks as an ISP, or would we like to go to a CDN that has those relationships? One of the interesting things, in particular for this generation of Freeview connected TV, is that the streaming protocols aren't widely supported by any of the CDNs that we've met with. So we are in proprietary land here, which is why we actually serve out on our own capacity for our own network. And this is where our own ISP capability comes into force. However, the future technologies do take us into HLS, and that is something that we want to talk to CDNs, find out their capabilities. Frankly, it all comes down to that price per gig and that reach and that availability to decide if we go down a CDN route or the internal ISP route, or maybe a mixture of both. But that's actually work going on at the moment. So I hope that answers that.
So just to sort of re-answer your first half of the question as well, whereas we went for a kind of Esperanto H.264 format for the streams, we did not go for an Esperanto streaming format for the streams. So we do provide differently wrapped streams for different devices because they're all, some of them only work with flags set to true, and some other devices will only work with flags set to false. And so, again, even the HTTP server is all entirely our own from the ground up, and that's not, we're not sat on top of Apache or something, because without rewriting great swathes of Apache source code, you couldn't deliver to as many devices as we do.
Quick question: how long did it take you, and how much of the time was allocated to planning and testing?
How long did it take us to do what? To build the platform, or to right to build the platform? When did we start it? It was in just before Christmas, wasn't it? I think it was in the late autumn we started it, and our first service went live in May. And that included all the platform testing, the application testing, because one of the things you've got to bear in mind here in our little world of broadcast is that the applications that especially the applications that we transmit out over the air, let alone the ones that come back over the internet, if we get so much as one line of code wrong in that, we can blat 16 million set-top boxes in people's homes. So we have no right to put that application out into the wild without going through ultra-rigorous testing. So we mentioned the DTG earlier and 370-odd boxes, as well as our own set-top box farm that we have down in Winchester. We do absolutely rigorous testing with those, with all devices before we actually open things up to the wild. But yeah, to answer the question in terms of how long it would take us, it's probably about 5 to 6 months before we actually went live with our first service from the day we literally started.
We were pedaling
the first
quite
bit.
hard.
Oh yeah, it was a real effort.
It was a couple of months in there doing the testing. So there was more time.
Yeah, it was literally all hands on deck for the testing over quite a period. I mean, the nice thing was the project was structured in such a way that we were able to get certain stages in build completion that allowed us to kick off testing in one portion of the infrastructural applications before we do others. And thankfully, we built ourselves a lab environment in advance, and it gave us the ability to build dev test stage type environments, replicate DTT muxes, so we can simulate every single DTT mux in the country in our lab environment, so we could actually try everything out in every permutation in a closed environment. It's a bit of an investment, but definitely worthwhile, and still proves to be so, actually.
Yeah.
It's not a question to do with technology at all, but I was interested that it gives you the capability, or gives channel operators the capability to turn, when their channel goes off there on from the old-fashioned transmission system set up in the evening, that they can turn into an IP stream. Are you able to share with us at all what the cost saving is for that allows them to do that?
I can.
Yeah, that's right. Yeah.
Ballpark 8 million a year for a Freeview channel. Ballpark $250,000 a year for an IP channel. Pretty big cost.
But you've got to argue right now that the reach of the IP connected is a subset. So yeah. Today.
Yeah, reach is different. Yeah. Freeview reach is 98.5% in the UK, 22 million homes. Our connected services probably hitting 2.5 million homes at the moment. Freeview HD boxes, people that bother to connect them to broadband. So reach is different.
I think increasingly one of the things you're seeing is that most tellies in the last sort of 6 months to a year will now come with Wi-Fi out of the box. Because a year or two ago, you had to physically plug an Ethernet cable into a big chunk of them, and obviously a lot of people, won't do that because they don't necessarily have an endpoint somewhere near the main telly. So as Wi-Fi technology increases, that's, I think, will have a big impact on increasing the ubiquity.
That's it. I mean, it's very early days for us. You saw the kind of channels we're currently broadcasting, but you know, we're at a stable point now. Actually, we feel, we were just saying the other day, actually in the office, that it feels like the platform, even though it's only been around for a short while, it's kind of reaching its adolescence now. We've gone through the teething problems, and you know, to the stage where we're now looking to engage with some of our larger broadcast customers and see if there's any potential things that we can do for them. And if that were to happen, and there's services that are actually of value to end users out there, this is the kind of thing that may get the market to start plugging in their boxes, and that could change the game quite well, we hope. So it's that sort of thing. So.
Guys, we've run a little bit over, so Instagram will be on the little tabletop with the Cellmark sticker on the wall behind it, and thereabouts for the rest of today and tomorrow. So, but thanks, guys, and thank you for coming.
Thank you.